We want to find the resistance RAB, that's the resistance seen from terminal AB. So it's a very simple circuit again. We have 20 and 30, these two, 20 ohms and 30 ohms, these two in parallel, and then that combination is coming in parallel with 40 ohms and 10 ohms. So let's first find the equivalent, parallel equivalent of 20 ohms and 30 ohms. So I will draw this again here, 10, 40, 10 ohms here, 40 ohms here, and here we will have the new resistance which will be equivalent, parallel equivalent of 20 and 30. So 20 times 30 divided by 20 plus 30, that's 50. So we have 412, 4 here, so 12 ohms. So that's the equivalent. And then we have 5 ohms here and 50 ohms here, and here we have terminal A, terminal B. Now I will erase this part to minimize, to simplify basically, sorry. So these two are in parallel. Let's find the parallel equivalent of these two, 10 and 40. 10 times 40 divided by 10 plus 40, that's 50. So we have 2, 8. So the equivalent, parallel equivalent of 10 and 40 is 8. So I will erase one of them, and then I will rewrite the value, the parallel equivalent value, which is 8 ohms. So now we have 8 and 12 ohms, these two in parallel. So the equivalent is 12 times 8 divided by 12 plus 8, which is 20. So 96 over 20, which is 4.8 ohms. So again I will erase one of them, maybe I will erase this part. So 4.8 ohms. So this value will be 4.8 ohms. And now we have very simple arrangement here. 4.8 plus 5 plus 50 ohms. These three are in parallel. So that becomes 59.8 ohms. So RAB 59.8 ohms. 4.8 plus 5 plus 40. These three are in series. So that's the resistance seen from terminal A and B.